Hello student, this video lecture is prepared for heat transfer subject for diploma student, and I will discuss the unit number 6, that is evaporation. In previous lecture I had discussed the points, that is what is meant by evaporation, what are the common examples of evaporation, and how to evaluate the performance of evaporator, that is capacity and economy. So now we will discuss how to calculate the economy, boiling point elevation, and then material and enthalpy balance, that is heat balance for single effect evaporator. So in previous lecture I had discussed about there are two factors which is used for the evaluate the performance of the evaporator is capacity and economy. So capacity we have already discussed that it is the number of kilograms of water vaporized per hour, and then in this lecture I want to discuss the evaporator economy, how to increase that economy. So economy of an evaporator is defined as number of kilograms of water evaporated per kilograms of steam fed to the evaporator, or it is also called a steam economy. That means if you feed a 1 kg of steam to the evaporator, how many number of kilograms of water is evaporated, that is called a economy. So in single effect evaporator, the amount of water evaporated per kilogram of steam fed is always less than 1. Hence the economy is 1. That means what is meant by single effect evaporator. So I will show, this is the figure. So this figure is single effect evaporator. That means only one evaporator is used here. So you have to feed the material from here. You have to add the steam. The steam is condensed by giving heat. The vapors of solvent is created and we get concentrated liquid here. So this is called a single effect evaporator, and in this case the economy is always less than 1. So if we can increase the economy of the evaporator by using two methods. One is use of multiple effect evaporation system, and second one is the vapor compression system. So first we will discuss what is meant by multiple effect evaporation system. So if we look at this figure, this is called a multiple effect evaporation system. So multiple means instead of one evaporator there are 2-3 evaporators are connected in a series. That is called a multiple effect evaporator system. So what is happening in this evaporator? You have to feed the material here and steam here. Then after heating the feed material, the solvent vapors are created. That solvent vapors are again fed to the second evaporator, and concentrated liquor coming from first evaporator is fed to the second evaporator. Then again the heating is taking place here. The steam is vapors are condensed and the solvent is evaporated. So that solvent is using as a heating media for next evaporator, and concentrated liquor obtained from this second evaporator is fed to the third evaporator. So in this way we can connect number of evaporators here. So this system is called a multiple evaporator system. So here we do not discard the vapors produced by evaporator. So here the steam economy of that evaporator is increased, because we have only fed the steam here, and then vapor produced by this steam is used as a heating media. So we will discuss this part later in detail. And in this case the vapor produced by condensing steam are directly discarded, so these are not used. So therefore the economy of this single effect evaporator is always less than 1, and it is higher in the case of multiple effect evaporator. And the second method is known as the vapor recompression. So this is obviously used for heating, as a heating media. That means here if we compress these vapors, so the temperature of these vapors is increased, and again if we feed these vapors as a heating media to the evaporator, that is called a vapor compression. So there are different types of vapor compression methods, and that part we will also discuss in detail in a coming lectures. So here you must note that there are two types of methods of increasing the economy. First one is the multiple effect evaporation system and vapor recompression. So details of these 2 points will be discussed. Then there is another term known as the boiling point elevation. So what is meant by boiling point elevation? The difference between the boiling point of the solution and that of pure water at a given pressure is known as boiling point rise. Sometimes it is called a rise or elevation of the solution. That means what is the boiling point of the solution in that evaporator? Suppose here there is a solution. So what is the boiling point of the solution in that evaporator at a given pressure? At the same time, what is the boiling point of pure water at given pressure? So if we minus these two things, then we get the boiling point elevation, okay, or boiling point rise. So there is a rule that is known as During rule. So according to During rule, the boiling point of a given solution is a linear function of a boiling point of a pure water at a same pressure. Okay, so if we plot the graph between boiling point of the solution and boiling point of the water, we get a linear means straight line graphs for different concentration, and this type of a plots is called a During plot. So here if we look at the x-axis, the boiling point of the water is given at a different pressure, and in case of y-axis, boiling point of the solution is given. So suppose if we want to calculate this is for NaOH. If we want to calculate, suppose for 30% concentrated solution, you have to take the boiling point of the water from here. You have to go this line and then again move in this direction to y-axis. So here you get the boiling point of the solution. And if we take the difference between this and this, then we get the boiling point of that solution or evolution. So in this way we can calculate the boiling point elevation. So this is required in a calculation, so that we will discuss while solving the problem. The next part is we will discuss the material and energy. Enthalpy means energy balance for the single effect evaporator. So here we are going to discuss only single effect evaporator. That means only one evaporator. So this is actually block diagram of the evaporator. And so in this block, so this is the evaporator. You have to provide the heat. Q means heat. Then you have to provide the solid material. This is called a feed. Okay, so feed is having mf kg per hour weak solution. That means dilute solution containing W1% of solute. Suppose 10% of sugar solution is if you feed, that is known as the W1, and remaining is the water or other solvent, we can say. So generally water. Then after evaporation we obtain two products, that is some thick liquor is obtained and the solvent is evaporated. So this is the thick liquor obtained is called m dot. So this is called m dot, and here we get W2% of solute by weight. That means the concentration of the solute is increased. So it may be from 10% to 30%, 4% to 25%. Okay, so here we get the concentrated solution and some water is evaporated, that is called a m dot v. So overall material balance is given by kg per hour of feed is equal to kg per hour of water evaporated plus kg per hour of thick liquor. So if we put the values, that is mf, or we can say m dot f also, is equal to kg per hour of water evaporated is m dot v plus kg per of thick liquor is m dot. So this is the overall material balance. So that means we are having solute plus solvent balance. In all these parameters we have considered that solute plus solvent. So it is called a overall balance, overall material balance. Then we will discuss the material balance of the solute. So solute is nothing but, suppose sugar is the solute. So in this case we are having sugar here and here. Okay, so here there is no sugar present because it is a water which is evaporated. So if we want to do the material balance for the solute, we have to get these two parameters. So here solute in feed is equal to solute in thick liquor. That means how many solute is feed here and how many solute you get from thick liquor. So you have to equate that. Input is equal to output. So solute in feed is given as W1% and total feed is m dot f. So you have to multiply with that, and it is given as a percent, so divided by 100. So in this case also we obtain W2% of solute from m dot and divided by 100. Okay, so why 100? We have given these solutions in a percentage, so for that purpose we have to divide by 100. So 100 get cancelled and we get this equation, that is 6.3. W1 into m dot f is equal to W2 into m dot. So if we know the three of the above mentioned out of 5, then we can calculate the 2. That means if we do the material balance of this, and then we can obtain the value of evaporated or kg per hour water evaporated or kg per hour of thick liquor. Okay, so in this way we can do the material balance. So here I want to conclude this lecture. So today's lecture I had discussed about evaporator economy, the definition, then what are the methods of increasing the economy of that evaporator, and then I had discussed the definition of boiling point elevation during plot, and at end of the lecture I had discussed the material balance for the single effect evaporator, that is overall material balance and material balance for solute. And in next lecture we will discuss the enthalpy balance for single effect evaporator and type of evaporator. So thank you.